Yes. Do I have what? Okay, if you do not yet have a piece of paper, you will want to make sure you have a piece of paper. You can use the back of your book or whatever too, that's fine. So what I would like you to do is, if you were here yesterday, which most of you were, I would like you to write down any words that you learned during the POGL. Okay, so what words were you focusing on during the POGL? Because we're going to do a little debrief and make sure everybody understood everything. Feel free to discuss with your neighbor. You didn't know what barbecue was like before that? I can think of 6 off the top of my head. Can you think of more than me? And you may have known these words before. Oh, I thought of another one. It's 2 words, actually. Okay, who's got an A for me? Bova. Adam. Who's got an M for me? Brian. Molecule. Who's got an E for me? Ooh, electron is good, but we didn't focus on it in the POGL yesterday. Tristan? Sorry? Element. C. No? Yes? Compound. Ooh, another M. Mixture. P. Particle. And then we have one that's like CB. Chemical bond, yes. Pardon me? Pure, oh, I forgot that one too. Pure substance, thank you. So basically what we were doing last day was we were classifying matter, okay? And we could say start with all matter, can be classified as either, there's two big categories. Out of all of those words, what do you think are two big categories? Have a little chat with your neighbor about that. Could be. If I said that this category was pure substances, what would the other category be? Mixtures. Okay, and within pure substances, what can you say about the particles in pure substances? Yes? Yeah, all the particles are the same. So we could have a pure substance. Yeah, no, that's good. And in a mixture, you will have different particles. Now, we're going to learn a little bit more about mixtures later on, but for today, let's focus on our pure substances. There are two types of things, once again from our list, that are pure substances. So we've used the word pure substance, we've used the word mixture. Two of the things that are left are considered pure substances. See if you can chat with your neighbor and figure out what those two things are. Yes. The question is, what are the two types of pure substances? So we're going to take pure substances and break it down into two more types. Have a chat about it. What of these, of the rest of the things on there, which one can you say is a pure substance? Just making everything plural. Which of those things are pure? Yes. Atoms. Well, you could have, let's say you had atoms that looked like, a sample of atoms that looked like this. Is that a pure substance? No. So atoms aren't necessarily a pure substance. Okay? What is a pure substance? Which one of these things could be considered a pure substance? Compound. So if I have a compound, like water, H2O, for example, and I had a sample of that compound, what would each of the molecules look like? Do you guys know what water looks like? Two hydrogens and an oxygen, and it ends up looking like a little Mickey Mouse almost. Yeah? So every single water molecule would look like every single other water molecule, even if they're upside down. So compounds are pure substances because the particles are all the same. Can you think of another thing on that list where the particles are all the same? Sorry? An element. So here we could have our little picture as an example. We have our water, H2O. Yeah, of course. There's a sharpener here too. You have a sharpener. Oh, yeah.
It's one of the ones that.
Oh, because you need a garbage can now. Yes, go for it. For something like that, we're just going to assume you can just go do that, okay? Because again, we're going to assume that the garbage cans are part of our classroom because it is silly otherwise. I have to tell you, I'm not very impressed so far by how it's going. Like in the did I tell you guys in the staff room? Like the there's the landfill one and there's the organics one. Okay, so landfill goes to the dump and gets like burned and whatever, and organics gets composted. I'd like you guys to tell me, where would you put paper towels? Compost. See, you know that. Do you think the staff knows that? No, there were tons of things in there, so I had to put up a sign. Paper towels go in organics, even though there's like a sign and it actually has literally like a picture of a paper towel above that. So anyway, I was not so impressed by how we were doing, but hopefully you guys are doing better than the staff because you guys are very clever. All right. Elements are also pure, and we could have an element that looks like this. Or we could have an element that looks like this. This is an atomic element. What do you think we would call the other one? This one is made of individual atoms. Yeah. No, compounds need to have compounds need two or more different atoms. So H2O has H's and it has O's. What do we call particles that have two or more atoms stuck together? It is one of these words up at the top. Which one of these words? Yeah, molecules are two or more atoms stuck together. So we could have an atomic element, or what might we call this one over here on the right? Molecular. Armando, you need a piece of paper. Okay, so that takes care of our pure substances. They're either compounds or they are elements. There's no other choices. That's it for pure substances. Okay? And if it's a compound, you're always going to have like different things. And if it's an element, the atoms are always going to be all the same. Okay? Do you see how in both of them have the particles are all the same. Compounds, particles are all the same. Elements, particles are all the same. But in an element, even all the atoms are the same. Whereas in a compound, you need different atoms in the molecule. Okay, and we're not going to talk about them today, but we are just going to add a couple things to mixture just so they're on our little chart here and we can talk about them later. Mixtures. So if we go back up to mixture, there's two types of mixtures. And you may or may not have heard their names before. They are homogeneous. So we have homogeneous. Anyone want to guess what the other one starts with? This is a homogeneous mixture. You might be able to figure out what the other type is called. Even if you're too shy to tell me, see if you can figure it out and tell your partner. You might be able to guess. Does anyone think they know? You don't even have to tell me. Does anyone think they know what the other one might be called? You think you know? No? Starts with an H. What? Homogeneous and anyone think they might know? You don't have to tell me what it is, you just might know. Were you right? Did you think maybe? Yeah? Heterogeneous. I told you you might be able to guess because we know those prefixes from the words homosexual and heterosexual. The prefix homo means the same. Okay, so people who are homosexual are attracted to people of the same sex. Hetero, can you guess what hetero means? Hetero means different. So a heterogeneous mixture actually, let me go grab a couple of mixtures for you to look at. Okay, here we have two mixtures. This mixture is copper chloride. Okay, copper chloride is a blue salt. Okay, so it's a blue crystal, and you can dissolve it in the water. Okay, so this is one of our mixtures. This is another mixture, and I think we've got oil on the top, and then we've got some liquid of varying densities on the bottom with various colors. I would like you to tell me which of these two is homogeneous and which is heterogeneous. Could you please point to the homogeneous mixture? Yes, this is the homogeneous mixture because it all looks the same. This is the heterogeneous mixture because different parts look different. Now this one is easy to tell that it's a mixture because I told you that there's water in here. What color is water? It's colorless. Yeah, water is colorless. It's got no color. So obviously this water must have been mixed with something blue. So sometimes it's easy to tell when you have a mixture. What's happening is that the particles become so small that you can't see them. They are mixed very, very thoroughly. There's thorough and even mixing, so you can't see the differences between the particles. here I have some, here I have some binder clips, and I have some paper clips. Is that a homogeneous mixture or a heterogeneous mixture? Binder clips and paper clips. Heterogeneous, yes? It's pretty straightforward. All right, that's it for this. All right. Is there any part of this that you would like me to go to so you can copy it down or anything? Maybe I should just make this bigger again. Ooh, actually, we should probably draw a picture of a heterogeneous mixture. So if you're looking at the particles, and I'll give you a minute to draw this because it's a little bit tedious to draw. And yours doesn't have to look exactly like mine. But what you want to make sure is that your drawing of the heterogeneous mixture has clumps. Do you guys know what the word clump means? Okay, a clump means that there's little groups of particles kind of conglomerating in one area. They're all like, there's little sections where we just have the little black ones. Yeah? Now the homogeneous mixture, I've sort of run out of room, so I'm going to kind of attach it like that. Remember, what's the mixing like in homogeneous? The mixing should be thorough and even, which means that I will not have clumps of these little black things. How many did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9, right? And they're all separated out. And all around them, we have the little white ones. And you'll notice what we have in the homogeneous mixture. Are there any clumps? No clumps. Are we good? I'll give you another minute. A few people are still writing. And then we're going to go to page 5 of our workbook, okay? Page 5. So with your neighbors, you're going to discuss which one is the odd one out. So in question number 1, you're going to take a look at these. And you're going to decide which one of these is the odd one out. That means 3 of them are similar and 1 of them is different. Which one is different? Have a chat with your neighbor once you've picked one. See if you picked the same thing as your neighbor. Okay, what do you guys think for number 1? Is it copper, gold, salt, or sulfur? Salt, yes. Now, I'm going to write down the formula for each of these. You guys might be able to tell me the formula for copper. What is the formula for copper? The symbol for copper. Cu. Capital C, little u. Anyone know the symbol for gold? Au. Capital A, little u. And what is the symbol for sulfur? S, capital S. Now, does anyone happen to know what salt is? Yes. NaCl. That's capital N, little a, big C, little l. And one thing you're going to notice is if we write the formula, if we have 1 capital letter, how many elements do we have? 1 element. If we have 2 capital letters, where'd it go? No. Ah! Oh, that's okay. If we have 2 capital letters, how many elements? 2 elements. And if we have 2 of them right side by side touching, if we have 2 elements touching, what do we call that? Yeah, if they are touching, that is a compound. Okay, so we have copper is an element, gold is an element, sulfur is an element, and NaCl is a compound because it's got those two capital letters and they are touching. They're not separated by a comma. They're not separated by space. They're not separated by an ampersand or a plus. Okay, so those are a compound. Now take a look at group 2 and see if you can decide which one is the odd one out. Tell your neighbor what you think. Which one does not match? We have rust, silver, water, wood. What is it, Tiana? Silver, yeah, it's silver, okay? Because silver, Ag, is what? Silver is an element. Now, rust, does anyone know what elements rust is made out of? You might or might not know. Anyone know any of the elements in rust? Iron oxide. So it is Fe 2O3. Iron oxide. That is a compound. Hopefully you all know the formula for water. What's water? H2O. That is a compound. And wood is actually made of a bunch of different stuff, but mostly it is made of things that are made of carbon. We don't know how many. Hydrogen, we don't know how many. And oxygen, we don't know how many. So I put X for the carbon because I don't know how many carbon atoms there are. It's going to depend on where in the wood it is. Yes? And HY stands for, so it's carbon, hydrogen, and oxygen. In fact, most wood is made of sugar. It's just bonded together in a way that our bodies cannot digest. If you were a termite, you would have enzymes in your gut that could digest the wood, but we don't have those enzymes. So who's the odd one out? Silver. Okay, group 3, who's the odd one out? Plastic, yes, because we have helium, He, oxygen. Does anyone know, is oxygen just O or is there something else? O2, yeah, oxygen is what we call diatomic. It's made of 2 atoms. Here's an interesting thing about plastic. Plastic is also C something, H something, O something. Ooh, interesting. Do you know what plastics are often made from? Gasoline. Okay, so like petroleum, that kind of thing. Do you guys know where petroleum comes from? It comes from, it's a fossil fuel. When people, animals, plants, trees die and they get squashed under like loads and loads of soil over millions and millions and billions of years, they get squashed and they undergo chemical reactions and they become petroleum. So it's no wonder that wood, which got squashed and digested and whatever over millions of years, eventually turns into petroleum, which can then be turned into plastics. So they're all made of carbon, hydrogen, and oxygen, just arranged in different ways. Remember, if the atoms are arranged different ways, you have a different substance. Okay? And potassium, anyone remember the symbol for potassium? It's a funny one. Okay. So we have an element, compound, element. And finally, our last group. Who is the odd one out? Sand, yes. And that's because sand is a compound. It's actually called silicon dioxide. Anyone want to take a guess as to the formula for silicon dioxide? Silicon is Si. Si and then what? Dioxide. What do you think di means? Di means how many? 2. So how many O's do you think there are? 2. So it's going to be SiO, and the little 2 goes down at the bottom. Okay, watch where you put those little numbers. Those little numbers go down at the bottom. Carbon, of course, is C. Bromine is capital B, lowercase r. Magnesium is capital M, lowercase g. But bromine is another one that needs a 2. So it would be like a Br atom attached to another Br atom. What do we call this attachment? What is that attachment there? That is a chemical bond. Is good? Okay. There are many different materials in this world, but only around 120 elements. These elements can be combined in many different ways to make thousands of different, what do we call them when they're combined? When elements combine, they form? They do form molecules, but if I take different elements and combine them, what do I get? Compounds, yes. So just so you're aware of this, we've got some copper here, and you can see all the copper atoms are identical to one another. It's made of only copper atoms. Carbon is made of only carbon atoms, and helium is made of only helium atoms. An element is a substance made up of only one type of atom. Okay, so if you have an element, you only got one type of atom. Is an element a pure substance? Pure or mixture? Pure. Okay, excellent. molecules of elements. Some atoms of elements join together. What do we call it when they join together? When atoms join together. It's page 6 now. You looking for something, Carson? Like that? Okay. What do we call it when elements join together? What do we call that joining process? Bond. When they join together, when they bond. And when you have atoms joining together, what do they make? Molecules. So atoms, single, molecules, more than one together. Okay? One of the elements that exists in a molecule is hydrogen. Hydrogen joins up with another atom of hydrogen. Okay, so we have a hydrogen atom. Two of them together make a hydrogen molecule. Now I want you to think back to our atomic structure unit. Let's draw a little tiny Bohr model of hydrogen. Not hard to draw because there's only one proton and how many electrons? One electron. So here's hydrogen. It's got its one little proton and it's got one electron. I'm going to draw another one. I might draw it in a different color here. Man, I cannot draw circles today. They're all like wibbly wobbly. So we have two hydrogen atoms. What do atoms like their shells, their outer shell to be? They want their outer shell to be full. Does hydrogen have a full outer shell? No. Wouldn't it be nice if this hydrogen could share its electron with the other hydrogen, and the other hydrogen could share its electron with the first hydrogen, and then they would both have two. Okay, so what's going to happen is we're going to have our red hydrogen with its electron, and our black hydrogen is going to kind of overlap and now they are sharing two electrons. That gives red hydrogen a full shell. That gives black hydrogen a full shell. And if you think about it, if you have a positive charge, and then you have a little negative charge and a little negative charge, and then you have a positive charge, what does positive do to negative? Positive attracts negative. So we get the positive nucleus attracting the negative electrons that are being shared, and the positive nucleus attracting the negative electrons, which are shared. That attractive force, that's a chemical bond. So not only do they have a full shell, which makes them really stable. Are you looking at your phone? No? Okay. Not only are they really stable because they have a full shell, but if we go back over here, you can see we have those positives attracted to the negatives in between them. Isn't that nice? Okay. And because you guys have been so good today and have listened so well, and I've gone yammering on and on and on, what I'm going to have you do right now is that we're just going to take a little break from that. And you are going to do page 12. You are going to classify these things as either a pure substance, which is an element, or B, a pure substance, which is a compound, or C, a mixture of elements, D, a mixture of compounds, or E, a mixture of both elements and compounds. Okay, give that a try. Hi. Okay, so you're going to look at this and you're going to say, is this a pure substance or a mixture? I don't know. Pure substance? Pure, because all the particles are the same, okay? And then you have to decide, if it's a pure substance, is it an element or is it a compound? Elements, the atoms are all the same. Are all the atoms the same? No. So that is a compound because it's made of two different types of elements. Does that make sense? So you have a pure substance, which is a compound, so that's a B. This one, is this a mixture or a pure substance?
Pure substance, no.
Mixture, because the particles are different. Yeah, different. So is it a mixture of elements? Like, is that an element? Well, you just have one type of circle, right? It's an atom. So you have the black element and you have the white element. Are there any compounds in here? No. So you have a mixture of elements. Yeah? Okay. What is that? Okay, so what do we have here? What's that? It's E. Yes. Okay, you think you got it? Give the rest of them a try. I'll come and check in with you. I want to go around and see how other people are doing too. Let me just turn on the lights here. Okay, that's good. That's wonderful. It is. All right, so just right here. It's an element. It's an element. It's E. Shut up. Dude, yeah. Oh, God. What's wrong with you? Stupid. What is that? No, I said that. You said elephant. No, I said I said pure substance because it's all the same. And it's a compound because each part of the elements. Okay. Okay. You sure can. Well, this one, I think that was our separate for another. They're not bonded together. You have to have an hour that they flat. White out. So is this, are the particles the same or are they different? They're different, so a good different. So do we have a mixture of elements? Or do we have a mixture of compounds? Are there any compounds? All elements, that's a mixture of elements, yeah. That one's all different. Okay, so what we've got here, you've got this type of particle, right? Right? I got two different types. So here's mixture. Now we have to decide, is that particle made of that element the atoms are the same, so that one's an element, element. So you have both element and we have a mixture of elements.
Oh, yes.
One more. There's two different lines.
Wait, isn't
So is it a mixture of elements or these are these elements?
Yeah, no, you're right. Yeah.
They're compounds. So you don't. All right. So this one.
Maybe from the card.
Yeah.
Same. Okay, choosing the same size. Okay, so elements are the same. So for example, this one here. Yeah. That's just all these things. Yeah, so you got element, white element, mixed black, right? Yeah, do you see any of them where you have left over? There's just so already out of the package. So I'm talking anywhere. All compounds are they all the same? They're all the same. Yes.
The last word is
It almost looks like a compound, but it's not. Atoms are the same.
Don't even talk about that.
Thanks. This one, the outer same, so that is not. So if it's all the same, it must be so that it can be here. Okay. If you want to go, explain it to me. Always like asking a question, let's not ask how you can just explain it. Are you gonna answer it? Hello. Yes, I have. Yes. So now we have all sides of a element. Yeah. Did you watch that?
Oh, yeah.
I just kind of, yeah, I'm sorry, I forgot I was on Tuesday. Do you want to do it today? Do you want to do it like a town class? I'm okay. Okay, well, we'll start it now. Okay, and we're not gonna use the stand for this one, I only got one tomorrow, it's not a big deal. And I will, if you finish this, I'll give you the next part, okay, if not, we can do that another time. Yes. Okay. Is there anyone else who was away yesterday and did not get their test back? Just Gavin? Okay. Hi.
The correction thing, conflict on the
Yeah, that's okay. I forgot it was Tuesday and I had a thing anyway. When would you like to do that?
maybe tomorrow.
Sure. Yeah. Yes, you should have periodic table for that. Do you need one?
Oh, yeah. I got it.
Okay, so I guess you're not ready. Because then you're like here. I was supposed to be able to go to chicken. And then. Oh, wait, never mind. I just need, that's 10. The extra coffee, yes. Stop.